Welcome ninth grade extended students. Today we are going to discuss deductive structure and statements of logic. This is sections 1.7 and 1.8 in our book. Throughout geometry, we're going to use deductive structure. This is where conclusions are justified by means of previously assumed or proven statements. Deductive structure contains each of these different items. The first is theorems, and theorems are statements that have been proven. So statements that have been proven. Postulates are statements that we accept as true without proof. Generally speaking, they're very obvious. Undefined terms, and there are three undefined terms in geometry: point, line, and plane. And those are the building blocks of geometry. All the different geometric figures we talk about consists of putting points, lines, and planes together. And definitions. Definitions can be stated in if-then form. And they define an object or term. Let's look at one definition. If a point divides a segment into two congruent parts, then the point is the midpoint of the segment. So this form is called conditional form. In conditional form, we have if hypothesis, then conclusion. So right now our hypothesis is a point divides a segment into two congruent parts, and then the conclusion is the point is the midpoint of the segment. Now, we can flip the hypothesis and the conclusion, and when we do that, we call it the converse of the conditional statement. So the converse of our statement above is if a point is the midpoint of a segment, then it divides a segment into two congruent parts. Which do we think is easier, proving something true or proving something false? If you prove something true, you have to prove that it is true always in every single case. In order to prove something false, you only have to find one instance where it is false. We call that finding a counterexample. A counterexample makes the hypothesis true and the conclusion false. So, proving something false is easier. And to do that, you find a counterexample. A counterexample makes the hypothesis true and the conclusion false. As soon as you find one counterexample, the whole if-then statement is false. In this example, we're given a statement that a passing grade is a D or better. I want you to write the converse of the following statement and determine whether or not each statement is true. So my statement is, I passed my test. If I passed my test, then I got a B on my test. I want to know if it's true or false and why, and then I want you to write the converse and determine whether it's true or false and why. Press pause on your video when you're ready for the explanation. Press play again. Okay, here are the answers. The first statement is false. My counterexample is this. I passed my test. My hypothesis is true. And I got a C. The conclusion is false. So I got a C on my test, not a B. I still passed. It's false. I made the hypothesis true and the conclusion false. The converse is, if I got a B on my test, then I passed my test. That's true. A pass on a test is a D or better. A B is better than a D. There are other forms of statement of logic besides conditional form. Conditional form is the if-then structure. So if hypothesis, then conclusion. The other form is the declarative form. And here's an example. So my conditional form is, if two angles are straight angles, then they are congruent. The declarative form says two straight angles are congruent. As we start to discuss proof in geometry, the conditional form is much more natural to use. Here are some different forms of statements. So in the first example, I have my declarative form. Two straight angles are congruent. Negation means I want to state that my previous statement was false. So if I negate that statement, what I say is that two straight angles are not congruent. When I negate a statement, I say that the statement is false. So in declarative form, if I say something is congruent, the negation is that they are not congruent. Now, if I want to make the statement in conditional form, if two angles are straight angles, then they are congruent. The converse, like I had said, is when you flip it. So let's look at that first. I would just flip my conclusion and my hypothesis and say, if two angles are congruent, then they are straight angles. The inverse of a conditional statement negates the hypothesis and the conclusion both. So my inverse would say, if two angles are not straight angles, then they are not congruent. That is the inverse. It negates the hypothesis and the conclusion both. So in an inverse, I negate both. The contrapositive flips and negates. Okay, so I'm going to look at my converse and I'm going to negate each of those. Flip it, negate. So if two angles are not congruent, then they are not straight angles. So once again, when we have our conditional statement, the converse is obtained by flipping the hypothesis and the conclusion. I get the inverse by negating the hypothesis and conclusion, and I get the contrapositive by flipping it and negating both. I want you to practice now. I want you to take this statement: if M is the midpoint of segment AB, then M, A, and B are collinear. Write the converse, the inverse, and the contrapositive of that statement. Press pause on your video, and when you're ready for the explanation, press play again. Here are my answers. You'll notice that I highlighted the hypothesis blue and the conclusion pink. That way it makes it a little bit easier to see what's going on. Remember, for the converse, I'm just flipping the hypothesis and conclusion. So my pink comes first, my blue comes second. If M, A, and B are collinear, then M is the midpoint of segment AB. For the inverse, I negate both of them. I do not flip. If M is not the midpoint of segment AB, then M, A, and B are not collinear. Negate each. For the contrapositive, I negate the converse. So if M, A, and B are not collinear, then M is not the midpoint of segment AB. Now I want you to look at each of these statements, and I want you to decide whether they are true or false. Also, whether the conditional statement that I gave you to begin with is true or false. Press pause on your video. When you're ready for the answers, press play again. Here are my answers. So my conditional statement was true. If M is the midpoint of a segment AB, then M, A, and B are collinear. That's absolutely true. My converse is false. If M, A, and B are collinear, then M is the midpoint of segment AB. Now, it's always nice to give a counterexample, but in this case, the counterexample is easier shown as a picture. So I can draw M, A, and B so that M is not the midpoint, and that is my counterexample. I only need to find one counterexample. The inverse is false as well, but I first have to put in the word not. If M is not the midpoint of segment AB, then M, A, and B are not collinear. So if M is not the midpoint of segment AB, then M, A, and B are not collinear. Let's take a look at that. To show that it's false, I want to draw a case where M is not the midpoint of segment AB, but M, A, and B are collinear. I want to make the conclusion false. And the picture from my converse still works. So let's take a look. A, B, M. So you can see in this case, M is not the midpoint of segment AB, but M, A, and B are still collinear. So this statement's false. The contrapositive actually is true. If M, A, and B are not collinear, then M is not the midpoint of segment AB. In order for M to be a midpoint of a segment, it has to be on the segment and therefore collinear. If a conditional statement and its converse are both true, then that statement is biconditional. All definitions are biconditional. So if I write my conditional statement and its converse, we can write what we call a biconditional statement. So here's an example. If points lie on the same line, then they are collinear. The converse is, if points are collinear, then they lie on the same line. This is the definition of collinear. To write this as a biconditional statement, we put the words if and only if in the middle of the hypothesis and the conclusion. So points are collinear, if and only if they lie on the same line. And this is shorthand for both of those statements. Now, mathematicians are essentially lazy writers, and they got sick of writing if and only if, so they abbreviate it IFF. Going along with the theme of mathematicians being lazy writers, there is symbolic notation that goes along with conditional statements and each of the different types of statements that there are. So if I have this statement here, we're going to call this hypothesis, this blue part, N, rather than it is a nice day. And that is the hypothesis. N is the hypothesis. Then Ms. V rides her bike. B is the conclusion. Ms. V rides her bike. The symbol that goes for negation or not is that. It's a tilde and it looks like a squiggle. It means not. So if I want to write my conditional statement in symbolic notation, I would say N implies B. That's how you write an if-then statement with symbols. Now remember that the inverse is what I get when I negate the hypothesis and the conclusion, but I do not flip anything. So in symbolic notation, I would write my inverse statement as not N implies not B. The converse I get by just flipping it, so I would change the order. B implies N. And again, the contrapositive is what I get when I flip and negate. So I'm going to negate the converse. Not B implies not N. And that is much faster than rewriting each of those sentences. I'm going to write each of these in symbolic notation and show you how chain of reasoning can work. So the first statement is if Ms. V is eating an English muffin, then she used a toaster. So I'm going to write this as E implies T. If it is morning, then Ms. V will eat breakfast. I'm going to write this as M morning implies B breakfast. If Ms. V is using the toaster, then she will hurt her hand. So if toaster, then hurt hand. And then the last statement is if Miss V is eating breakfast, B, then she will be eating an English muffin, implies E. So we can put this together in one big chain or transitive property. And what we want to do is link all the pieces together. So if I have M implies B, that's this guy. Let's see where B goes. B implies E, that's that guy. And then E implies T, that's that guy. And then T implies H, that's that guy. So we could jump from M to H. So if we can link all that together, then we know that M implies H. Or if it is morning, then Ms. V will hurt her hand. Now, a conditional statement and its contrapositive always have the same truth value. So if the conditional statement's false, the contrapositive is false. If the conditional statement is true, the contrapositive is true. So we say that a conditional statement and its converse are logically equivalent. They produce the same truth value every single time. I want you to look at each of these statements, and I want you to come up with a conclusion by using chain of reasoning. But first, I'm going to give you the letters that go with each statement. So we're going to call G gremlins grow grapes. We're going to call statement E elves eat earthworms. We're going to call T trolls tell tales. And we're going to call statement W wizards weave willows. Okay, so take a look at these statements, write them in conditional format. You might need to negate it, write the contrapositive of some of them, and try to link them together. Press pause on your video, and when you're ready for the explanation, press play again. So when I did this, I wrote it out symbolically, and then I wrote the contrapositive for each. So if gremlins grow grapes, then elves eat earthworms. So G implies E. The contrapositive is not E implies not G, because these are logically equivalent. If trolls don't tell tales, then wizards weave willows. So not T implies W. I could also write that as not W implies T, flipping and negating. If trolls tell tales, then elves don't eat earthworms. T implies not E. Contrapositive, flip and negate. E implies not T. So you're looking for ways to link all these together with chain of reasoning. And I was able to do it two different ways. If I started with G, G implied E from here. E implied not T. That was my last statement, the contrapositive of my last statement. And then I was looking for a not T to hook that up with. Not T implies W. That's the conditional statement from my second statement. And then I was able to link G to W. G implies W. So if gremlins grow grapes, then wizards weave willows. Alternatively, I could have linked things together this way. So I know not W goes to T, then I'm looking for where T goes to. Well, T goes to not E. Where does not E go to? Not E goes to not G, and therefore not W implies not G. If wizards don't weave willows, then gremlins don't grow grapes. These are conditional and contrapositive statements of each other. Now it's time to practice. I have put the assignment on Schoology, so get to work on that now. Have a wonderful day.